In an earlier video, I talked about how to name straight chain hydrocarbons. Those are hydrocarbons that are molecules that are made of hydrogen and carbon and have a straight chain like so. These are all hydrogens coming off of here. And so what you do is 1, 2, 3, 4, 5, go down to 5 carbons is pent, and all single bonds, so this would be pentane. But let's see what happens if we actually have some side groups coming off. So for example, we could have a 2-carbon side group hanging off of our middle carbon. The way that you name this is you find the longest chain. That means without backing up. So if I go straight across, 1, 2, 3, 4, 5. If I go 1, 2, 3, 4, 5, still 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it doesn't matter which of those, since they're all 5, it doesn't matter which one I pick as my main chain. But to make it easy, I'm going to choose the one that's straight across like this. It doesn't matter if you decided to go down that way, you're going to come out with exactly the same name. So you name the parent chain. So the parent chain is the longest chain that you can find of carbon-carbon bonds that doesn't back up. Like we can't go 1, 2, 3, 4, 5, back up 6, 7. No. So no backing up. So our parent chain is 1, 2, 3, 4, 5. We said that already that was pentane. Name the parent chain, and then anything that comes out of our red circle there, anything hanging off of the parent chain, has to be named in front of the parent chain. So we had this side group right here. We're not going to count this carbon that's in the parent chain because we've already named it. When we said pentane, we were saying 5 carbons. We just need to name these 2 coming down here. Well, 2, if we go over to our chart, 2 carbons is F, is our prefix, and since it's a side group, we add a YL. So side groups or side chains end in a YL, and we use our same prefixes for that. We also need to say which carbon it came off of, and this is numbering from our parent chain. If we number from the left, it's 1, 2, 3. If we number from the right, it's 1, 2, 3. So it doesn't matter which way we number this one. It's going to be 3-ethyl pentane. Let's try some more. All right, so our first task, remember that we would have hydrogens sticking out all around here, but I'm just gonna keep it in this skeleton view because I think it makes it a little bit easier. If you're confused on one, it helps a lot to take the hydrogens out and just look at it like this. So we need to find the longest chain. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our longest chain we found was 7. And to get 7, we had to go like this. So this is our parent chain. And 7 carbons is hept, H-E-P-T. Since they're all single bonds between the carbons, it's heptane. And we need to name our side groups. We have 2 hanging outside of the red this time. We have this one, and we have this side group. This one's by itself. These 2 are together. So this one that's by itself, we're going to look over here for 1 is meth, and then it's a side group, so methyl. And this chain over here, side group, is 2 carbons, so that's an ethyl, ethyl. To decide which one comes first and which one comes second, you put them in the name alphabetically. So E comes before M. So we're going to put the ethyl first. Remember, we need a number saying where it is. So if this is carbon 1, 2, 3, 4, then our ethyl group is coming off of the 4th carbon in our parent chain. So it's 4 ethyl. Then we have a methyl group coming off of carbon 1, 2. Don't change your numbering, like don't number this way for this one and then this way for this one. Always keep your carbon 1 as carbon 1. So it's coming off of carbon 2, and it is a methyl group. So this tells you the parent is heptane. It's got a methyl group hanging off of carbon 2, an ethyl group hanging off of carbon 4. So the number goes in front of the group. So the group tells you the location of that group. So the number goes with the name that follows it. Let's try another one. This one's going to be tricky, finding the parent group. But remember, we want the longest one that we can find that doesn't back up. So I want to use this side, and if I go straight across, I just get one more, but if I go down, I get 2 more. So notice your parent group can bend all over the place. 1, 2, 3, 4, 5, 6, 7, 8 in the parent group. So that's going to be oct, all single bonds, ane, octane. And we have 2 groups hanging outside of our purple parent chain. We have a methyl group here, and we have another methyl group here. So we have 2 methyl groups. And we want to start counting at the end of the chain closest to the groups. So if I start here and make this carbon 1, this is carbon 1, 2, 3, 4, 5. This one would be 6, 7, 8. So I'd have one off of the 3 and one off of the 6 if I number from this end. If I number from this end, and this is carbon 1, 2, 3, 4, 5, 6. Well, they come out the same. So it doesn't really matter on this one, since it's symmetrical either way. It doesn't matter which way you do it. But if it was not symmetrical, you count from both ends, and whichever one gives you the lowest numbers. And if you're not sure, add the numbers together, and the lowest total will tell you which you should use. So we have a methyl group coming off of carbon 3, and we have another methyl group coming off of carbon 6. Since there's 2 methyl groups, we're going to put dimethyl. And because of this di, that means 2. That means you better have 2 numbers in front showing the locations. Let's try another. This one has a double bond in it. The double bond has to be in the parent chain. So this part has to be in the parent chain, even if it makes it shorter. So here's our parent chain. Even if we had another carbon down here, so it would have been longer to go this way, we wouldn't have. We would have gone this way because of that double bond. Also, the double bond takes precedence over all the side groups. It's more important than all the side groups. So you have to number from the end closest to your multiple bond. So this is automatically going to be carbon number 1. So 1, 2, 3, 4, 5, 6, 7 is hept. Double bond is ENE, and you have to put a number in front of this saying where the double bond is, because it could be anywhere in here. It's between carbon 1 and 2, So that's 1 heptene. So that 1 is the location of the double bond. Now in front of that, we need to put the names of our side groups. Well, this one is a methyl, this one is a methyl, this one is a methyl, this one is an ethyl because there's 2 of them hanging off. So remember, we do it alphabetically, so ethyl before methyl. So 1, 2, 3, it's off the 3rd carbon, so 3 ethyl. And this time we have 3 methyls. We have a methyl on 1, 2, 3, 4, 5, 5, and 6. We need to put all 3 numbers, even if 2 of them are the same, so that we know that 2 of them came off of carbon 5 and 1 came off of carbon 6. And now since there's 3 of them, it's trimethyl. And so when you see this tri, you better have 3 numbers in front, even if some of them are the same number. Let's try a cyclic compound, a ring structure. When it's written in this format with a geometric shape like this, each vertex, each corner is a carbon. So this ring has 1, 2, 3, 4, 5, 6 carbons in the ring. Even if it would be longer to go this way, the ring is always the parent chain. So if there's a ring, that is your parent chain. 6 corners means 6 carbons. We go down to 6, and that's hex. They're all single bonds in between, so that's hexane. And to indicate that it's a ring, we put a cyclo in front. Now we need to name our side groups, and we have a methyl, we have an ethyl, and this one has 3 carbons. 3 carbons is prop, so this one is a propyl. Remember, side groups end in the YL. Numbering these can be tricky because you can start anywhere in the ring and you can number clockwise or counterclockwise. So you have to figure out the way that's going to give you the smallest numbers. And the way that would give me the smallest numbers on this is if this is carbon 1, this is 2, 3, 4, 5, 6. So I have side groups on 1, 2, and 4. If I went this way, starting with this as being number 1, it would be 1, 4, 6. Well, 1, 4, 6 is bigger. We want the smallest possible. So try starting in different locations, try numbering around different directions, and come up with what's going to give you the lowest side group numbers, and that will be its name. Now we have an ethyl, a methyl, and a propyl. So alphabetically, our ethyl will be first, and we said that was off of carbon 4. So we have 4 ethyl. Next would come methyl, alphabetically. It's on carbon 2, so 2 methyl. And lastly, on carbon 1, I'm going to have to write it up here, we have 1 propyl. So our final name is 4 ethyl, 2 methyl, 1 propyl cyclohexane. So that's quite the complicated looking name, but I hope that you see that it's just very methodical and it's not difficult to follow the rules and get the correct name. The last thing I'm going to talk about is if you have a side group that is not carbons. And we're going to talk about the halogens. If we look at our periodic table, the halogens are this column right here, column 17, right next to the last column, which is the noble gases. These are our halogens. And so fluorine, chlorine, bromine, iodine would be potential side groups. Here's a molecule for us to name. Again, it's a lot easier, I think, if you take off the hydrogens and just have the carbon skeleton with anything that's not a hydrogen. So we have a Cl down here, we have an F over here, and everything else are hydrogens, and we don't have to name the hydrogens because they're named in the parent name. So our carbon chain, our parent chain, is 3. So 3 is prop, single bonds in between, propane. But we have 2 side groups. Chlorine as a side group is chloro, and fluorine as a side group is fluoro. So you take off the INE and just put an O. Now alphabetically, chloro is going to come before fluoro. It's in the middle, so it's on carbon 2. So we're going to have 2 chloro. Now be careful on fluoro, because if you count from this side, 1, 2, 3, it's on carbon 3. But if you count from this end, 1, 2, 3, it's on carbon 1. And we always want to use the lower. So this is 2 chloro, 1 fluoro, propane. Let's come up with a crazy example and see if you can name it. Let's put a double bond in here. All right, this has everything. It has a multiple bond, it has branches, it has halogens sticking off of it, it has a carbon side group, it has everything. Now remember, when finding the parent chain, the double bond has to be in the parent chain. So we know this part is in the parent chain. If we look to the left, we can go straight and get 1, 2, or we can turn and go down and get 1, 2, 3. So 3 is more. So this is parent chain. Now we're going to look at this one. This is part of our parent chain. We're going to go down, we're going to turn, and we can either go to the right or go straight. It does not matter, because either way you just have 1 carbon. And now we have 1, 2, 3, 4, 5 side groups to name. Now our double bond is right in the middle. If it was off center, we would start counting on the end closest to it. But since it's in the center, we can number this from either side, because either way this is going to come out 4. 1, 2, 3, 4 between 4 and 5, or 1, 2, 3, 4 between 4 and 5. So since it's symmetrical like this, we can go ahead and name it and figure it out our numbering in a minute. So we have 1, 2, 3, 4, 5, 6, 7, 8, which is oct, double bond, ENE, octene, and our double bond is on carbon, between carbon 4 and 5. So don't forget, if you have ene or yne, YNE is a triple bond, you have to have a number in front saying where that is. Now if we look at this, we remember we're trying to keep the numbers as low as possible. I think it's pretty obvious that we're going to start with this being carbon 1, because it's closest to most of the side groups. So this is going to be carbon 1. We have a methyl. Iodine is iodo. Take off the INE, put an O. We have another iodo. We have a fluoro, and we have another methyl. So alphabetically, we have M, I, and F. F is going to come first. So numbering from here, it's on carbon 5. So we are going to have 5 fluoro. So that takes care of that one. Next comes I, and we have 2 of these, and they're both coming off of carbon 3. So we're going to have 3, 3, diiodo, which is pretty weird. So since we have a di here, we need to have 2 numbers in front. Even if they're the same number, it just shows they're coming off of the same carbon. So that takes care of that one. and that one. And now we have these two methyl groups. By the way, when you're doing your alphabetizing, don't take into account the di. Just use the I in iodo, because we're going to have a dimethyl here. Don't look at the D and say, hey, that should be in front of the F. No, we're looking at the M, the name of the side group, not any prefix it might have on it. So we have a methyl on carbon 2. We have a methyl on carbon 6. So 2,6 dimethyl, because they're two methyl groups. And that's about as difficult as it gets. I hope this has helped. Come back and check out my other videos if you have questions about other chemical issues, and feel free to leave me comments if you found this helpful or if you have ideas for other videos you would like to see. Have a great day.